Hello everyone, welcome to the Solidity Fundamentals course. I am Anjali and I'll be your guide for this course. In today's lesson, we are going to discuss about a user-defined data type known as structs. So till now, we have discussed all the primitive data types like signed, unsigned, integers, booleans, strings. But these data types like structs are a little different from the existing data types, and we will be looking at the implementation part as well as the initialization part in detail. So, starting with structs, what are structs exactly? They are user defined complex data types. So, as I told you, structs are user defined data type, means, for example, signed and unsigned integers are some existing data types which are provided by default by the Solidity language. But due to certain use cases, the users or the programmers, they require a certain type of data type, a organized collection of different data types together as a particular entity. For that, structs come into picture, and that's why they are known as complex data type, because one struct is composed of various other data types. So as I told you, it is derived from existing data types. So one struct, or you can consider the struct as a group, maybe as a classification or as a group of multiple other data types. So for example, in case we are discussing about the courses here, so in case we want to discuss about the course which we are studying, and I want to create a struct out of it because I want to segregate the meaningful information for that struct together at different place. So what I'll be doing is I'll be creating a struct name course, and I'll be writing the features to it. This is same as you create an object of classes in other programming languages. So in other programming languages also you have the concept of structures. So structs are similar to that. So what I'll be doing is I'll be creating a struct named as course, wherein I can have sub data fields, like I can have an unsigned integer which can represent the course ID. It can be a numeric value. Then there can be a string which can represent the course name. Then there can be a boolean value which tells you whether that course is free, this particular course is free, or it's paid course. So for like this, you can have multiple courses, right? In a complete in a full website, you can have multiple courses. Some can be paid, some can be free. The names of the courses will be different, the IDs would be different, but still you can get the point that these things, the all the three entities, the ID, the name, and the boolean value, whether it's paid or not, is related to each other for one single type. So when you want to club those types, so using the existing data types, you want to create a data type of your own. That is where structs come into picture, and that is where we use it. So structs are highly useful in Solidity language. You will see multiple use cases of structs, because as we know, we are discussing about contracts, we are discussing, and Solidity is an object oriented programming language. So there are a lot many times you will see practically that you need a specific entity which you are talking about, and that entity has some features, and in order to denote those features, you would be needing some subfields in the form of existing data types. So always, most of the times when you will be needing a struct, you will be creating your own struct. You will be mentioning the data types which you want, the name of those data types whichever you want to keep, and that's the style where you will be creating your own data type. That's why it is known as the user defined data type. So one example, as I told you, is this, that you, so this is how you initialize a struct. You write struct, this is the keyword, s with small, and then you give the name of the struct. For example, I'm naming it to be course. I'm keeping the three fields for this struct. One is the unsigned integer course ID, other is the string which denotes the course name, and third is a boolean which says whether it's free or not, true or false, whether it's free or not. So this is the struct, this is a user defined struct. So as I told you, the structs are used for grouping the related data. So as we know that course ID, name, and paid or free course, this information is related information for a single entity, single course. That's why we are clubbing that entity, that information into a single struct which is known as the course. Now, the important point about structs is that they can be declared both inside as well as outside the contract. So, we will be going into the details in our further lessons about this, but right now, for your understanding, most of the variables till now, whatever we saw, we used to start our contract and we used to write those variables at the contract level, right? But in case of struct, you can declare a struct outside the contract also. Why will you do that? Because then by then, if you import that contract into other contracts, then you can directly use that struct in those other contracts also. So declaring a struct outside contract means the scope is global, means if any other contract is importing this file wherein you have mentioned your struct, then they can be used by this struct can be easily used by that other contract also. So whatever the use case for it, we will be discussing in our advanced level topics then. But for now, you should just know that you can create a struct both inside as well as outside the contract. Now, structs can be initialized by three ways. First is calling it like a function. So we will be seeing all these three ways in our Remix IDE shortly. So first one of it is that you can simply write it like a function. So as you can see, I can use the name of the struct, and I can start and function round bracket, and I can pass the attributes, whatever I want to pass. So this means this way of initializing a struct is a function way of initializing a struct. Second is a key value mapping. Here it's more readable. So obviously this is more time consuming, but in case you want to make your code more readable, this makes more sense that you are mentioning the key and then putting a colon and then putting the value in curly brackets. So this is known as key value mapping. This is like a JSON structure, if you know what if you have worked with the JSON objects. So this is similar to that. So this is like key value mapping. This is to make the code more readable. In case your code is to be dealt with people who want to have more readability in your code, then you can use this kind of coding. Third is you can initialize an empty struct and you can assign values later on. So in case your code demands that you need to just keep the empty struct with you initialized, and dynamically you want to add some values using functions, so then you can probably write course memory C. So here you have to use a keyword memory or storage. So for structs, you need to mention the storage types. So we will be discussing the storage types in detail in our upcoming lessons. For now, either you can write course memory C, or you can write, whether if you want to store the struct in a memory, then you have to write memory, otherwise you can write storage as well. So course memory C or course storage C. Then you can mention the C, all the attributes using C dot course ID, C dot course name, C dot is free. So this is the third way of doing it. I'm sure that you would be confused reading about all this. So this will be clear to you once we write the code in our Remix IDE. Then you will be easily able to see it. We'll deploy the code and we will see the values also which are returned. So now let's write the code for our struct. First, let's declare a struct. So with a small s, we write struct. I give it the name course, curly brackets open. And now first entity, we discuss the data type to be course ID. So you unsigned integer type course ID. Then let's write string course name. And finally, we had a boolean which says that is free. Okay. So now we have declared a struct. We have declared it inside the contract, but you can declare it outside as well, as we've already discussed. Now let's first see the first way of initializing this struct. The first way is using the function like call. So what we are going to see, so this is very similar to the other types. What we used to do, we used to write unsigned integer, boolean, whatever is a data type. So here the data type is named as course. So course. Then we used to write the visibility, we are making it public. Now we are giving the name to this variable C1, right? So this course is the data type, our own created data type, then the visibility, then C1 is equals to. So this is the first way of initializing it. I am writing the struct name and I am writing it in brackets, and here I am passing the values in order. So remember, this order has to be followed. So first I am passing maybe an ID, a numeric ID, so it should not be, sorry, in quotes, it should, because it's an unsigned integer, it will be passed like this. The name, Solidity, and is paid, is free, true. So let's call it a free course, right? So this is one way of initializing the course. We will be seeing after deployment the values which are set to this C1 course shortly, but this is the first way of initializing the code. Now the second way of initializing would be, as I told you, to make the code more readable. So course public C2, then I'll be writing course, and here in curly brackets you will be first mentioning the keys, course ID, then putting the colon 10101, whatever, then course name, then Solidity, and then again is free, and that is true. This is the third way of writing, the second way, sorry. Now coming to the third way, here we are going to only create an empty struct by saying course public C3, that's it. And we will be initializing it later on whenever it is required. Now we know this, we have already done that state variables, either you can declare it then and there itself, or you'll have to use a function. So here we'll have to use a function. Let's name it set value, and let's pass our values here. So we'll be passing an ID, then we'll be passing a name. So in remember, when using string argument in functions, you always need to pass memory along with the string to tell that string has to be stored in memory. We'll be discussing this part in our upcoming lessons. For now, just remember, with string we'll have to write the memory keyword, and I'm passing the name, then finally I'm passing the boolean value is free. And in my, I'm making this function as public curly brackets, and here in this function I am going to write that C3 dot course ID should be what? ID. Then C3 dot course name should be what? Name. And C3 dot is free should be what? Underscore is free, whatever we have passed in our function as arguments. So that's it. So this is how we write it. So these are the three ways. Now what? Let's deploy. So I've compiled the code. You can see that it has compiled successfully. Let's deploy it. Okay. Now this is it. So let me just zoom it a little. Yeah. Now as you can see, this is the deployed contract, right? So here, first of all, as you can see that first was C1. So if I click on C1, you see course ID has been set, the name has been set to Solidity, and is free has been set to true, because we were directly initializing it. C2 is same as C1, only that we've made it more readable by using the key value mapping. So let's click on C2. Again, you can see the ID has been passed, name has been passed, and boolean. But C3, we have created an empty struct. So if you click on C3, you see by default, and now you know in Solidity there is no concept of null. So by default, course ID is set to 0, blank string, and boolean has been set to false. So as I told you, by default, these are the defaults of Solidity. So for setting the values, we have written a function called as set value, and we'll have to pass the arguments here. So I'm passing 1001 as ID, I'm passing Solidity as this course name, and again I'm passing true as a boolean value. Now I'm calling the set value function. So the moment I've called the set value function, now if I click on C3, you see the values have been updated. So this is the third way of writing a struct. So that is it. These are the three ways of initializing a struct, working with structs. Structs are very commonly used. We'll be implementing structs a lot in our upcoming lessons. So for now, you should just know how to initialize the structs using these three methods. See you in the next lesson.